Hi, thank you for joining us for our virtual CU Anschutz Wellness Series, Happy and Healthy Hour. I know some of you have joined us for our last few virtual events, and we're so thrilled that you're able to be back with us again this afternoon. For those of you who are joining us for the first time, we're really excited to have you. As members of the CU Anschutz alumni family, we want you to know that you're at the top of our mind during this tenuous time, and we're so proud of the expertise and support our alumni bring to their communities and our campus, especially in times like these. And my name is Taylor Triolo. I'm from the School of Medicine class of 2013 and the Vice President of the Medical Alumni Association. I'm also a pediatric endocrinologist at the Barbara Davis Center for Diabetes here at the Anschutz Medical Campus. This series was developed in response to feedback from our alumni that you're looking for practical tips to support your self-care as health professionals. And tonight's topic is going to look at how sleep impacts your health and immunity and tips to help you improve it. And so now I have the privilege of introducing tonight's speaker. Dr. Dan Bessesen is the director of the CU Anschutz Health and Wellness Center, a professor of medicine of endocrinology, metabolism, and diabetes with the School of Medicine, director of fellowship training in endocrinology, and director of the Clinical Intervention and Translation Core of the NIH-funded Nutrition Obesity Research Center. And so thanks so much for being here tonight. I'm excited to hear your talk, and I'm going to turn it over now to Dr. Bessesen. Thanks so much.
Well, thanks, Taylor. More than anything, I'm an alumni. I was a graduate of the medical school in 1982 and was involved in the Alumni Association for a number of years. And I still think of them as CG, Colorado General, and DG, Denver General. Tells you how long I've been here. I'm here at Denver General actually this afternoon where I'm in clinic. I've been practicing endocrinology here at Denver Health for the last 30 years. And then I do my research and teach medical students over at the medical school. Today I'm going to be talking about sleep. We'll spend a little time on immunity, but I just want to kind of let you think about sleep and your health. And I must say, as somebody who thinks about lifestyle, and a lot of you probably think about your diet and your physical activity. And maybe you work to eat a good diet, a healthful diet, and get some physical activity. Sleep might not be at the same level for you in terms of thinking about the role of sleep in your health. And some of the reason for that is, well, you're sleeping when you're sleeping. When you're eating, you know what you're eating and you decide, am I going to put this in my body or not? The food that we eat, it physically turns into our body. And so I think eating healthful food, it's sort of obvious to us that that would be important. And physical activity, I think if you get out and move, you can tell if you're getting stronger and it gives you stamina. So those are kind of obvious, but sleep is a little bit less clear. I think the world has changed a lot. It's changed our diet, it's changed our physical activity, but it's changed our sleep as well. The world is not what it used to be. This is a picture of downtown Denver there at the Platte River in about 1840. And so picture yourself here in Denver a couple hundred years ago. When do you get up in the morning and where am I going to get my coffee from and where's my bagel coming from? It's a very, very different world. It required different levels of habitual physical activity and there's no lights here. And so when are you going to go to sleep and when are you going to get up? And how does that change in the winter time or in the summertime? Well, now our lives are very different. There's light everywhere. We're inside. It's not cold. The food's everywhere. So a lot of that is good. But our bodies evolved in an environment that looks a lot more like this and not so much like this. And so I think we're each faced with some choices about our health, about food, physical activity, but also sleep. So why is sleep important? I mean, when you think about it, I'm 60 plus years. A third of our whole life is spent unconscious. So 20 years of my life, I've been laying in bed or somewhere completely unconscious. That's amazing, isn't it? If you think about living in this world 300 years ago, the fact that you would just lay down somewhere and become unconscious for 8 hours, it must be something very important because obviously there's tremendous risk associated with not being able to protect yourself, defend yourself, respond to the environment. Sleep is fundamental. It's a fundamental biologic function like eating and breathing. Without sleep, we don't function. And this is true for all organisms, all the way down to flies. It's a key to our health and our well-being, our performance, how well we function cognitively and physically. It's important for our safety and for our quality of life. So that's my bottom line. If we finish this hour and what you come away with is thinking about your own sleep and saying, maybe I should invest a little bit of energy in my sleep, just like I do in my diet and physical activity, then I think I will have been successful. Let me talk a little science for a few minutes here. The sleep cycle was discovered in humans by electroencephalography. So that's the brain waves. And if you put electrodes on your head and you see what your brain's doing, what's an electroencephalogram? It's sort of like holding a microphone at 30,000 feet above Denver. You'll hear some noise, but it's hard to get much detail of what's going on. So this is just a broad view of what the brain is doing. But what people have seen is there's just very specific brain wave functionings that happen as we go to sleep. So you start to feel tired, it's 11 o'clock, you lay down in bed, and if you had an EEG on, there would be some kind of characteristics of early sleep and then deeper sleep, and then this unique thing called rapid eye movements. When we think about these sleep cycles, sleep occurs over about 8 hours every day. It's divided into the non-rapid eye movement stages, that's 1 through 3, and that's about 80% of our night. So these upper areas, most of our sleep is spent in those areas. This rapid eye movement, that's about 20% of our night. What do these things mean? And there's actually some other parts to this. There's something called sleep latency. So this is when you lay down, and for some of us, we're worried about what happened today, COVID, staffing, I don't know what it is, but that's the time it takes you to go from being awake to being asleep. And for some of us, when you were a younger person, maybe that would take 5 minutes. For some of us, this takes longer. N1 or stage 1 sleep, that's just light sleep. That's kind of drowsiness. Stage 2, that's deeper sleep and comprises about 40 to 50% of our total sleep time. Stage 2 and 3, these are the really important stages of sleep, especially stage 3. This is deep restorative sleep. When somebody's in this stage, it's difficult to wake them up because, and some very important biologic processes are going on here. The body is healing itself and important biology is occurring. Rapid eye movement sleep, if you look at the EEG, it almost looks like you're awake. There's a tremendous amount of neural activity going on. The eyes are moving, parts of the body are moving, muscles are contracting. So this is a very unique part of sleep. Dreaming happens during this stage, and this stage of sleep appears to be really important for learning and memory. What happens is you fall asleep and then you move through these 3 stages, some REM sleep, you go back up into these earlier stages, and so we cycle through these different stages of sleep about 4 or 5 times through the night. There's another term I'd like to introduce, which is WASO, or wake after sleep onset. Again, when I was younger, I'd go to sleep and I wouldn't wake up till the morning, but now sometimes I'll fall asleep and then in the middle of the night I'll wake up for one reason or another. So that is time when I'm fully awake, but it happened after I already fell asleep. So that's another term. We'll show you more about that as we go along here. So that's the basic description of what happens when we sleep. Well, when do we fall asleep? If you get tired, at some point you have to fall asleep. If you tried to stay up for 3 days, you couldn't do it. Eventually you just fall asleep. So there's these neural systems in the brain. One pushes us towards sleeping, and the other pushes us towards wakefulness. And there's this tension between these 2 neural systems. And they respond to a number of biologic forces and humoral mediators. We could spend an hour on this. But what essentially sleep need is like having a bank account. It's like a debt on your credit card. When you wake up, you're expending energy, interacting with the world. And as time goes by, those systems that push us to stay awake start to get weaker, and the systems that push us towards sleep get stronger. And at some point, you have to pay. You can increase the external stimuli with noise or sound. I remember when I was 30 years old and driving to California, I'd stick my head out the window of the car in the middle of the night and let the wind blow in my face. That would keep me awake. Not very safe. Anyway, so these are the biologic processes that determine the fact that we need to sleep. Sleep onset is somewhat linked to the presence of light, which stimulates central neural systems, which I'll talk about in a minute. And this is rhythmic. because normally, I mean, humans are awake in the day and sleep at night. Rodents like rats and mice, they're awake in the light cycle and then they sleep at darkness. But all these mammals are timed to a circadian or 24-hour cycle, with the idea that roughly a third of the day will be spent sleeping, and that will normally be aligned with darkness. That's how we're biologically programmed. What happens then is when we first wake up, melatonin is the key hormone that establishes this. This is made by the pineal gland in the brain. And so melatonin goes down, and then we wake up. And right after we are awakened, our cognitive functions, we're at peak alertness. And so functioning, reaction times, this is physical functioning, brain, cognitive function, they're good in the daytime. And then as time goes by, it gets to be evening time, our alertness, our reaction times decline. And then normally darkness would set in, and the timing of this darkness would be linked to melatonin released by the pineal gland, and we would fall asleep. And then through the night, we would cycle through those different stages, and in the 2, 3 a.m., we'd be in those stage 2, 3, those deep restorative sleep time. And this would be a normal cycle that we would do. And again, if you think about the world we live in, this would be normally timed to light and dark, the sunrise and the sunset. Ken Wright, who shared some of this information in some of these slides with me. Ken Wright's up at Boulder, and he studies sleep, and I thought this was a great study. What he was interested in is how light, natural light, affects our sleep timing, because so many of us live in a world where there's just light around for much of the day. So he did this camping study. This is a limited number of, I think there were 6 people, 6 men and women in this study. And what he did, he did 2 of these. I'm going to show you the one during the winter. And so what he did was, he took these same people and had them in a normal environment where there's electrical lights. This is their apartment and their home. And they had a device on them that could measure how much light they were being exposed to across 2 days. Here's one day, here's a second day. And then he had them go camping up in the mountains, and no natural light. They could start a fire if they wanted to, but no telephones, no TVs, no lights. And so this is what he recorded, how much light they're exposed to. What you see is that if you're up in the mountains, the sun comes up and there's a lot of light, and the sun goes down and there's no light. There's no light in the middle of the night. 2, 3 in the morning, you're up in the mountains, there's no light. But if you're in our environment, there's less light in the middle of the day because we're not standing out in the sunshine, and there's more light in the nighttime. So the stimuli for when should we go to sleep, when should we wake up, they're not what they naturally were thousands of years ago. And the effect of this is, so what he's showing here is sunset, sunrise, so we should be sleeping somewhere in here. And so this is during winter, so there's this long dark period. And what he's showing is, here is these people when they're living in a place with electrical lights versus natural light. And what he's showing is how much they sleep. These black bars are how much they sleep. So just being up in the mountains in the dark, people slept almost an hour and a half more than they did in a natural environment. And the biology of it, the melatonin onset, the melatonin midpoint, and the melatonin offset were shifted. So just biologically, people these folks were sleeping less and sleeping later in an environment with electrical lights. And that's what we've really found is over the last 150 years, people are going to bed later and they're sleeping less. And so just like our intake of sugar-sweetened beverages has gone up, our consumption of trans fats and things went up, this is a reflection of the modern environment. The modern environment has changed our fundamental biology of sleeping so that most of us are going to bed later, and it's biologically based because of the light that we're exposed to. Well, the way this thing works is there's a clock inside our body. Again, this is amazing biology to me. This was first discovered in mice who had a mutation in a gene such that they weren't sleeping in any regular pattern. They had to sleep, but they were sleeping randomly. And so they found a gene that seemed to control this. And that was the first clue to a system called the circadian clock genes. So when it was first discovered, it was discovered in the part of the brain, a suprachiasmatic nucleus, that keeps time and makes us go to sleep. And these cells have an internal clock that keeps this 24-hour biologic time. The master clock is in the suprachiasmatic nucleus, and it tells us when to go to sleep, and it controls that melatonin rhythm. It coordinates the timing of our behavior. Our activity, our brain activity, all of this, our performance, our general sense of well-being. So the amazing thing, though, is that all the cells in our body have little clocks in them. Once it was discovered that this controlled sleeping, then people said, well, are these genes found in other tissues? And the answer is yes. These little clocks are found in beta cells that control insulin secretion. They're found in muscle cells, they're found in fat cells, and they have important functions. So time and organizing a tissue function around what time it is critically important for the normal functioning of the body. There's a clock. A clock's got these little pieces, and the different parts interact with each other to keep time. This is the circadian system. I won't go through all the detail of this. It's fascinating biology. Suffice it to say, there's a variety of proteins here that control this clock. And just very simplistically, what happens is this is a gene transcription. So the DNA causes a protein or RNA to be made, and then a protein's made. So as that happens, these proteins accumulate. And what those proteins do is they'll interact with other proteins to shut off their own production. So what's happening is as the protein builds up, then it interacts with another protein, and that one decreases the level of the other one, so it goes down. Once it goes down, these ones go up again, and then these ones get made. So it's a little like a clock mechanism. It takes some time for the proteins to accumulate, takes some time for them to interact, takes some time for this to change the transcription of these, and then they fall because of the half-life of the proteins, and then it releases the restriction on this, and the whole thing goes around. So in some ways, it's highly complex. In another way, it's kind of simple. It's kind of like a clock. And so these proteins are present in pretty much every cell of the body. They were discovered in the brain, again, the suprachiasmatic nucleus, and controlled waking and sleeping. They respond to light and dark in the brain, and that's what controls those melatonin rhythms. But again, as I mentioned, these genes are present in pretty much every cell of the body, and they have effects in those other cells. This is a little bit of a complicated slide, but what it talks about is those are the proteins that are in that clock system, and there are mutations in these proteins. So if you take this clock out of a mouse, what happens? It overeats and becomes obese and gets metabolic syndrome. I mean, that's crazy. Actually, these are effects if you just take it out of fat tissue or muscle tissue. So even if it's present in the brain and the animal's sleeping fine, if the fat cell doesn't know what time it is, then it affects body weight. It affects glucose levels. It affects insulin secretion. That's in beta cells. And it changes motor activity. So who would have thought that, that clocks are important in the normal functioning of tissues like fat tissue in the liver? This is animal studies, but they're human homologs here. There are humans who have mutations in some of these genes, and look at what the phenotype is. Their weight is higher, they have metabolic syndrome, they have risk for diabetes, they have insulin resistance. So clocks are critical in a way that I think we didn't used to think about. I'm just gonna say one more thing about genes and tissue function. So this, again, science will stop in a second here. I know you want something practical. The reason I'm showing you this is, to me, this is a brand new idea. Here is clock genes in a beta cell that makes insulin. I used to think that insulin came out like you'd eat a meal and your blood sugar would go up and that would make insulin come out. But what we've learned is that these clock genes are present in beta cells, and that as the beta cell, the insulin secreting cell, grows, it gets used to feeding and fasting during the day. We eat in the day and we don't eat at night. How do we get through 12 hours at night without eating and getting hungry? It's because these clock genes tell our body time to sleep, not time to eat. So insulin anticipates this daily rhythm. So insulin isn't just reacting to meals, it's anticipating meals happening. Same thing's true in muscle. Muscle has these clock genes, and during nighttime, you're not having any food coming in. And so you have to burn fat. And it turns out these clock genes in the muscle, same thing. The muscle is anticipating that I'm going to be eating during the day and I won't be eating at night. So these clock systems and the organization around light and dark and sleeping, they're fundamental to all our tissues. So when we talk about, are you looking at your phone at night? Remember this biology. This is how your body works, is time, sleep, light and dark, and clocks are fundamental to the function of all these tissues. So let me ask you some questions. I should say here that I can't see them right now, but there's a chat function down there. And if some of you have questions, feel free to add some chatting. Or your questions, I can answer them at the end. So here's a question. How are you sleeping? Is your sleep great? Not enough? I get enough, but it's a poor quality. So go ahead and click on those boxes and we'll see what you guys say here. I'm going to go down here. Great, not enough, or I get enough. So what do you think? Someone's helping with me. So Noelle, I'll let you decide when you're going to show us the answers. What do we got here? I get it. So the funny thing is a minority, only 23% say it's great. 77% either don't get enough or it's of poor quality. That's amazing. So if I asked you, how's your diet? I suspect a lot of you would say my diet's pretty good. 70% of you are saying your sleep isn't where you want it to be. Maybe that's why you're at this lecture today. Oh, I'm sorry, Noel, did I do something bad? I want to go to my next slide, but it's not doing anything. Have I done something dangerous here? Oh, great. Thank you. So here's my second question. On average, how many hours do you sleep per night? The choices are less than 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, or greater than 8. Go ahead. How many hours do you sleep? You might in your mind also be thinking about what would be good. How much should I be sleeping? I'll let you share when you're done there, Noelle. Great. So most of you are saying 6 to 7. Look at you people, less than 4 hours. Oh my God, that doesn't sound good. People getting 7 to 8 hours, that's 35. So really 46% of you are getting more than 7 hours. That's how much we're really supposed to get. So most of you are not getting enough sleep. Who has the most insomnia? Men, women, no difference. What do you think? This is those of you in relationships or in your family where there's men and women in the house. Who's the one waking the other one up? Husband snoring, wife's having hot flashes. I'm sorry, that was really sexist. What do we got? Women have more insomnia. Yes, great. We'll look more at that. Thank you for your ideas there. So we're going to talk about problems with sleep because obviously some of you have problems with your sleep and many of our patients, the people we care for, do. There are these ideas of, so what kind of problems could you have with your sleep? Not enough, it's not at the right time, or it's disturbed. So insufficient sleep means not enough hours. Misaligned means it's the wrong time. This is people who do shift work. They're awake when it's dark and they're sleeping when it's light, and the body wasn't built that way. Disturbed means the person goes to sleep okay, but there's something that disrupts their sleep. This could be, as I alluded to in my rude comment, sleep apnea, or it could be things like pain, or something like stress, psychological problems, or concerns, or menopause, hot flashes, things like that. 30% of Americans sleep less than 6 hours a night. I think our poll looked about that way. 20% of the population works non-traditional hours. So that's a lot of, and some of you I know, some of you are nurses or physicians or pharmacists, and you're working late night shifts, and that's just not how the body was built. 30% of adults report maintaining difficulty initiating or maintaining sleep. So insomnia or difficulty sleeping is quite a common problem. 3% of obstructive sleep apnea, and most of that is undiagnosed. That's a low number, but that's a potentially serious health problem. that affects things like cognitive function and work performance. Here's a question: what happens to sleep as we get older? Do we sleep more as we age? Do we sleep less? We sleep the same as when we were young, or we sleep the same but we wake up more often? What do you think? Are we grading these, Noel? Maybe not. What do you got there? And the winner is, we sleep less and wake up more often. Great, that's what you thought. Thank you, good thinking. So we have some maybe experienced people. I'm becoming an experienced person too. So the general idea is we should be sleeping 7 hours per night on a regular basis. And that's true no matter what your age is. And that comes from authoritative guidelines from expert organizations. What really happens is when we are first born, we spend a lot of time sleeping. This is average plus or minus standard deviations. And as we age, we sleep less and less, such that when we're over 65, 7 to 8 hours. Think of your teenagers though. How much are they sleeping? They need more sleep than adults do. Young adults need more than older people. Is it just how many hours we're in bed? What actually happens to sleep anatomy as we get older? Here's what happens from age 10 to age 85. The general amount of sleep time goes down, but some things are changing. Sleep latency tends to go up a little bit. That means it takes a little longer for people to fall asleep. The amount of time we're awake after sleep onset, I'm fully asleep, but then I woke up. Something happened that woke me up. That increases markedly for people. REM sleep goes down as we age. And really what we want is this stage 3, slow wave sleep. That is the deep restorative sleep. And that's what young people need a lot of and get more of than people who are older. So that's what happens with aging. So I think as we get older, probably it's important to spend even more time thinking about our physical activity, our diet, and our sleep. With more than 50% of individuals over 65 report difficulty sleeping. So this is very common. The poor sleep quality can be due to a variety of things. Underlying biology can change. People can have medical problems, psychological concerns, medications, diuretics at nighttime, sleep disorders such as insomnia, limb movement, or sleep apnea. So disrupted sleep is common in older individuals, and it has a variety of different causes. And again, if you have poor sleep quality, you could work with a healthcare provider to understand what those might be. And with age, there's that reduced stage 3, that slow wave, deep restorative sleep, and increased frequency of arousal. So even if you're getting a reasonable amount of time in bed, the quality of the sleep may be going down. So doing things to improve the quality of your sleep, I think is important, and we'll talk more about those in a minute. Why is sleep important for healthy aging? Again, I've emphasized that sleep's important, and women have more insomnia than men do, and some of that relates to the menopause and things that happen with temperature regulation there. I think good sleep quality, just like good nutrition and good physical activity, is a marker of successful aging. Though some of you are young people, and this seems like it's in the distant future, but just like you build good lifestyle habits in nutrition and physical activity, I think thinking of sleep as a core part of your health is a useful thing. Poor sleep quality is associated with a whole range of diseases and health conditions: heart disease, metabolic disorders, cognitive impairment. I'm going to talk more about those in a second. So getting good sleep helps your health, just like good nutrition and physical activity do. Here's some data on insomnia in women. As we alluded to, and you guys got the right answer, insomnia is 50% more in women compared to men. And that difference, the trouble with sleep, gets worse as women get older. Not sleeping well is a risk factor for emotional issues. This is, like many of these relationships, is bidirectional. If a person is depressed or anxious, they may have trouble falling asleep because they have a lot on their mind. But if somebody's not sleeping well, that is an independent predictor of developing depression and anxiety. And people who have sleep disturbances have more difficulty responding to psychiatric treatment than people who are getting good sleep. And women in particular are at greater risk for developing psychiatric conditions when they have sleep problems. So it's important for physical health, it's important for mental health as well. And menopause is one of the things that can disrupt sleep. Menopause is associated with poor sleep quality and increased symptoms of insomnia, which then affect daytime functioning and quality of life. Things like night sweats and nighttime limb movements can contribute to this poor sleep quality. Estrogen deficiency is occurring with menopause, and there are obviously pros and cons about estrogen use. Years ago, we suggested all women who went through menopause got estrogen, then the pendulum swung and we said nobody gets estrogen. I think the truth is problems with estrogen deficient related symptoms, such as disrupted sleep, are a reason that potentially estrogens might be beneficial. They need to be weighed against the risks of estrogen replacement therapy on an individualized basis. But I just want to be a voice for sleep's important, and night sweats and symptoms related to estrogen deficiency can disrupt sleep. Well, what are the health consequences of not getting enough sleep? And this has been extensively studied. What happened was maybe about 20 years ago, somebody realized we're sleeping less than we used to. And I think at the time, nobody thought sleep was that important. But the epidemiologists were the first to say, just do large surveys of thousands of people and say, how much do you sleep? Just like we did with you a minute ago. And then in thousands of people say, what's the risk of diabetes, heart disease, cancer? And what they found was those people who slept less tended to gain weight and tended to have more obesity. They clearly have more type 2 diabetes. They have higher rates of heart disease and strokes, more depression, impaired cognitive function and work performance, at increased risk for accidents, drowsy driving, crashes and falls, cancer. We'll talk a little bit about impaired immune function, and increased pain. The pain thing's bidirectional as well. If a person has pain, it can make it hard for them to sleep. But the opposite is true as well, or the converse. If you're not sleeping well, then people are more sensitive to pain-inducing stimuli. So not getting enough sleep can affect your life and your health in a negative way. The weight gain thing is super interesting. There are some experimental studies where they take a person and either let them sleep for 8 hours or have them sleep for 5 hours. And they measure things like hunger hormones, ghrelin and leptin. And then they put food around them and say, do the people eat? And the answer is sleep restriction changes the hunger hormones and the satiety hormones in a way that promotes food intake. And it promotes unhealthy food choices. It causes cravings for sweets and high-fat foods. There's a sex-based difference there. If you're not sleeping, you're moving around. So your energy expenditure actually goes up a little bit. So you'd think that would help your weight. But the appetite and the drive to eat is an even greater force. And that's why people tend to gain weight when they don't get enough sleep. Many of us are here at the Health and Wellness Center, we call it the COVID-15, not COVID-19. It's the 15 pounds we gained during COVID isolation. So people are on diets, and there's a number of studies that have looked at what happens if you don't get enough sleep and you're on a diet. And this is an example of one of those studies. And what they found was that people had similar weight loss, but let me see, I have it here. The weight loss was more fat loss with 8.5 hours sleep than with less sleep. So what's happening is you're going to lose weight if you go on a diet, but if you're not getting sleep, what you're losing is more lean body mass as opposed to fat mass. So not getting enough sleep promotes weight gain, and it inhibits our ability to lose fat mass when we go on a diet. How about immunity? This is what I was supposed to talk about. I find this super interesting. The immune system, people who study that are immunologists, people who study the brain are psychologists or neurologists. But that's a construct that comes from us. The body is one thing, and the brain clearly interacts with the immune system. This is peanut butter and jelly. This is salt and pepper. These two things work hand in hand, and they do that through a number of mechanisms. The brain communicates with the pituitary, which communicates to the immune system through hormones, like catecholamines or cortisol or growth hormone, and their bidirectional neural connections. This is amazing. If you take out a lymph node, that's a lymphatic tissue, and you do a histologic section, what you find is there are both efferent and afferent nerves. That means the neural system is monitoring the lymph node. It's getting information from the lymph node, and it's giving information to that lymph node. There are neurotransmitters in those nerve endings in the lymph node, and there are receptors for those neurotransmitters on immune cells. So the brain talks to the immune system. It is one coherent thing. So it's not surprising that there's interaction between the brain and sleep and those functions and immunity. The immune system clearly exhibits circadian rhythms. The secretion of immunoreactive substances goes up and down. The level of different types of immune cells goes up and down in the days, and the immune system cells have clock genes in them. Illness stimulates an immune response, which stimulates sleep. So this is sort of obvious. Many of us, and those of you who've seen patients with COVID, for example, COVID stimulates a dramatic immune response. And what do people complain of? They feel fatigue and they want to go to sleep. And so that fatigue and increased drive to sleep is a reflection and caused by the immune response that occurs. It goes the other way, though. If a person doesn't get enough sleep, then it changes the immune response. I'll just give you a couple examples. Vaccines are injecting something into the body that stimulates an immune response. It's an important thing. Hopefully we'll have a COVID vaccine soon, and they'll give us some kind of a protein probably, and then our body will make an immune response to that. Studies have been done in animals where you restrict sleep and measure the objective response to a vaccine, and it's reduced. So that's an example of how sleep restriction doesn't only cause problems with diabetes, insulin action, but also immune functioning. It's interesting when you compare people epidemiologically who have either short sleep times or habitually long sleep times. They both have an increased risk of infection. I think our hosts today wanted me to talk about this a bit because we're in COVID times. And I think the link here is those of us who are healthcare providers who are interacting with people who have COVID. I think getting enough sleep is one thing we can do that's part of an overall lifestyle that promotes good immune function. Again, experimentally in humans, if there's shortened sleep time and then you look at markers of inflammation, what you find is short sleep time increases markers of inflammation. And also, I think our ability to fight cancer, which is in part related to the cancer cells themselves, but also our immune response to that. Shortened sleep time and circadian misalignment epidemiologically are associated with increased risk of cancers, and there's some emerging biology on the mechanisms by which that might happen. Again, maybe I'm spending too much time on biology, but that last slide had a great review on this subject for those of you who are interested in the mechanism. This just shows that the brain is communicating to the immune systems through hormones like growth hormone, glucocorticoids, catecholamines, and that there are receptors for these hormones on immune cells. So it's not surprising that growth hormone pulsatility and levels are affected by sleep. Glucocorticoids go up if you're not getting enough sleep, so do catecholamines. So changes in sleep function affect the activity of our immune cells, in this particular model, Th2 cells, which give us this vaccine response, but also other inflammatory cells that make inflammatory cytokines, where again, catecholamines stimulate receptors on these immune cells, which stimulate a range of pro-inflammatory cytokines. Again, I'm sorry, I'm maybe getting too biologic here, but the reason I want to emphasize this is I think we often have this idea that sleep, well, what is it? I don't know. It's a powerful biologic force. So how about some specific causes of sleep disruption? Sleep apnea is one I think that is very important because it has a lot of physiologic effects. People who have sleep apnea have some nighttime symptoms. There may be frequent or loud snoring, gasping, or snorting sounds. I ask this of many of my patients, is there someone in the room who hears you while you're sleeping, and do you have this symptom? People may have trouble falling asleep, or they may be aware of waking up in the middle of the night. They may have restless sleep or difficult dreaming. They may be getting up to the bathroom at nighttime. So these are not specific symptoms, but somebody who has these symptoms, particularly if they also have daytime signs and symptoms, feeling fatigued or tired, lacking energy, feeling sleepy or falling asleep while they're driving or at work, sitting at their computer or falling asleep, feeling forgetful, foggy, fuzzy thinking. These are common, again, not specific, but somebody who has snoring, difficulty sleeping, and has some of these symptoms, one might think about sleep apnea. It can promote hypertension in the daytime, sexual dysfunction in men, and morning headaches. These are some of the signs and symptoms that we look for clinically. And of course, when I see somebody with a high hematocrit on a lab test, I wonder about this diagnosis. There are some screening questionnaires that we use for this. This is the Epworth Sleepiness scale. What they say here is you get a score like this, chance of dozing, a slight chance, moderate chance, high chance. So if somebody says, yeah, if I'm sitting there watching TV, I'm gonna fall asleep. Or if I'm sitting and talking with somebody, I'll fall asleep. So there's a score associated with this that would suggest maybe this is pathologic sleepiness. This is another simple questionnaire that gets at some of these. Do you snore? Are you tired? Has anybody seen you stop breathing while you're sleeping? Do you have high blood pressure? Is your weight high? Certainly, people who have obesity are more likely to have sleep apnea than people of normal weight, but it's not exclusive. Normal weight people can get sleep apnea too. Sleep apnea is more common as we get older. People who have a large neck size, that just means there's less space in the back of their mouth for the air to go through, so that's a predisposing factor. And women have more insomnia. Men have about 30 to 40% more sleep apnea than women do. Here's a scoring approach to this questionnaire. So these are clinical tools that we use to look for sleep apnea. And if somebody we think has sleep apnea, then we test their sleep. And there are different ways to test sleep. You could just keep a sleep diary. When did you go to bed? When did you wake up? How long did it take you to fall asleep, do you think? How many times did you get up during the night? That sort of thing. There are a variety of standardized questionnaires, which I won't go into, which have been validated and provide more detailed information on sleep quality. A lot of us now have phone apps that tell us about our sleep. These things tend to respond to movement, and they are of some utility, but they are not sufficient to screen for things like sleep apnea. The EEG is really the gold standard, but really in what we call polysomnography, we don't only just measure EEG, we measure there are electrodes to measure muscle contraction, so eye movement, changes in muscle tone, and also sensors that measure, are we breathing? Is the air actually moving? What's happening to our oxygen saturation? So really downtown polysomnography is all of these things. There are some home monitors that just use single lead EEG or some measure of oxygen saturation. And those are relatively good screening tests. They're not great for making a diagnosis. How does sleep apnea affect women? Sleep apnea does all the same things that it does for men. At least a fragmented sleep and cognitive dysfunction. Women tend to report other symptoms, especially insomnia, mood disturbance, rather than feeling fatigue or sleepiness. So the symptoms are a little bit different in men or women, and women may not respond to the screening test as good as men do. So I think there's a lot of undiagnosed sleep apnea in women. So I think I just have a heightened sense for screening women with a polysomnography for that. Women have more sleep apnea than men do, 30% more, but women are underdiagnosed relative to men. We tend to think of snoring and sleep apnea as being a male predominant, and it is somewhat, but women can get it too. Parasomnias is another general area. There are people who eat after they go to bed, and there's some treatments that can be prescribed for that. There are issues that relate to dreams and sleepwalking and other things. This is the kind of thing that if you or someone you know has a symptom at nighttime or while they're sleeping that is unusual and it's disrupting their quality of life, that's where a sleep specialist can be helpful. Cognitive abilities and mood. If we're not getting enough sleep, it can affect our mood, our ability to form and retain good memories. If you're tired, then your reaction time, your judgment, are impaired. You can have trouble completing text. Does this sound like any of us? I think many of us can experience some of these, and maybe you're aware of this, that when you don't get enough sleep, you become a little bit more irritable perhaps, your mood is not as good as it should be, you have trouble completing your tasks. And again, irritability, aggressive behaviors, these are things that are not good for our quality of life, could be helped by getting enough sleep. Cognitive functioning, again, what happens when we sleep is memory and core neural functions are locked in. And so if we're not getting enough sleep, then it can affect cognitive decline. If we look epidemiologically at people who aren't getting enough sleep or who have sleep apnea, these are risk factors for dementia and for cognitive decline in older people. And sleep apnea, which disrupts sleep, if you treat that, there's new data that this can improve or delay the onset of cognitive dysfunction. In fact, there's biology behind that amyloid beta deposits in the brain accumulate in animal models with shortened sleep time. This is a long litany of descriptions of disorders. Why am I doing this? And you may be getting fatigued with this. The reason, I guess, is again to emphasize, at the end of this, the question is, are you sleeping good? And your answers already were not so good. And then what do you want to do about it? And in between those is this important? And I think the answer is, it is important. So this is data about cancer risk outcome. So shortened sleep time can lead to obesity, insulin resistance, and these things are associated with cancer risk. So there's an indirect link. Epidemiologically, women with shift work have an increased risk of breast and endometrial cancer. And again, it's bidirectional. Women who are getting cancer treatments, that can affect sleep and quality of life. So it's an interaction between the sleep restriction can cause health problems. The health problems can also disrupt sleep. And safety. I guess maybe I'm coming to the end of these bad things that can happen. And you could imagine this. 27% of adults report being sleepy at work at least 2 days a week. So being sleepy is common. People tend to make errors and can be injured at work when they have a sleep deficiency. Some epidemiologic data suggests that there's a large number of sleep-related crashes, motor vehicle accidents, that result in both injury and fatalities. So if you're tired, me sticking my head out the window when I'm driving to California, probably a bad idea. Better idea would be to stop and get some sleep. Because most of us actually have driven while we're drowsy. I could ask you that question. How many of us have actually felt like we're dozing at the wheel? So this is potentially life-threatening, not just for us, but for other drivers on the road. There's a lot of medications that we have that can contribute to these things. There are a variety of drugs, psychotropic medications. There's also things we do, alcohol, caffeine, diet pills. So there's a variety of things that we do that contribute to insomnia. So I'm sort of moving here to what can you do about this? I think if a person has trouble sleeping, look at things that might be causing that, and medications are one part of that. There are also things that can cause sedation, and what happens is, again, the timing is important. So if you're sedated during the day and you cause napping, or you do napping during the daytime, now the rhythm is disrupted, and so you may not have good quality sleep at night. So these are some medications that somebody might use, say they're anxious and use a tranquilizer, now they're tired, now they take a nap. Now their sleep is disrupted. They're not tired when they need to go to bed. Because again, there's that tension between the forces that make us want to sleep and the forces that make us want to be awake. So trouble sleeping, look for both medications that are stimulants or sedatives that are causing daytime napping. Okay, now back to you. After you go to bed, Which of these do you? You can pick as many of these as you want. Do you ever go to bed and watch television, or listen to the radio, or look at your phone, or read from an electric reader, or look at your computer or tablet? What do you think? You don't do any of those things, do you? Maybe. Why do you do those things? It's going to help me go to sleep. Remember the biology. What do we got? Look at your phone. Look at that. 60% look at your phone. What are you looking at your phone for? It's just really 37% are watching television. Wow. So this is reality. This is what we do. We live in an environment where we feel like we have to get that information. But remember what I showed you about the camping. Light in your eyes changes your melatonin onset and makes it harder for you to sleep. And the result is your total sleep time is later and it's shorter. And what did we say? Short sleep time is bad for you. So we are doing these things that are disrupting our sleep. If you were one of those people who said, I don't sleep enough or I have trouble getting to sleep, these behaviors are part of the modern environment. It's just like sugar-sweetened beverages or something like that in our diet. This is the This is the sugar-sweetened beverage of sleep, I think. Here's another question. If you don't get enough sleep, why? Why are you not getting enough sleep? Is it because there's too much work, that you have trouble falling asleep? You can mark as many of these as you like. Stress, family, it's my husband, my wife. Actually, I don't think I need that much sleep. I do fine without that much sleep. What do you think? What I'm trying to do is get back at the underlying reasons. Many of you said you weren't getting enough sleep or good sleep quality. But have you asked yourself, what's the cause of this and what am I going to do about that? What do you think? I think it's the spouses. My wife says that to me. Or is it too much work? For you guys, it's too much work, isn't it? What do you think? Trouble falling asleep and staying asleep. And what is that about? You know what? 80%, that's what it is. And how many of you, though, said you were looking at your phones or looking at your tablet? So that sleep hygiene, that's the term that we use for it, is what you do around the time of going to bed. That's what's happening here at this onset of sleep. Stress is a big one, too. And what can you do about that? And I'm not talking about stress reduction. I know Liz Chamberlain talked to you some about that. Okay, here's some sleep tips for you. If you want to get better sleep, get on a schedule and stick to it. During the day, get some sunshine. Remember, light is the biology functions on light. So if you get some light, that will help those clock genes and the circadian system get aligned. Avoid medications that are stimulants, especially close to bedtime. Those are going to push that system that keeps you awake. And so if you're having trouble falling asleep, like 80% of you said, how many of you had caffeine at noon or 1 o'clock or 2 in the afternoon? Close to bedtime, maybe, but even I think afternoon. So really look at your caffeine use. Exercise, but not too close to bedtime. And avoid naps. If you're spending your sleep debt with a nap, or you're paying back your sleep debt with a nap, then you're not tired when you go to bed. And 80% of you said you're having trouble falling asleep. So don't nap and don't use sedative medicines in the daytime that do that. What else? And so you all taught, 80% of you said getting to sleep is the problem. So this is sleep hygiene. These are the basics. So about 2 hours before you go to bed, dim the lights in your house so that you can get your clock to prepare for bed. It's dark outside. Remember the camping thing. It is dark and that people go to sleep. What do? It gets dark, you turn all the lights on in the house. And so what are you doing? You're putting the light into your pineal gland and it thinks it's daytime, it thinks it's not time to go to sleep. This is a biologically driven system. So get those lights down. Hour before you go to bed, engage in relaxing, non-alerting behavior. Why? Because if you go to bed stressed, it's going to be hard to go to sleep. So kind of try to chill yourself out before you go to bed. Don't eat or drink too much because it's hard to digest that while you're laying down. And maintain a dark, preferably cool, but comfortable sleep environment. And don't turn the lights off, turn the sound off, don't get too hot or warm, because then that may wake you up. So make the sleeping space comfortable for you. How about a nap? Sometimes we have to take a nap just to maintain functioning, but avoid naps when you can, and do it for as short a time as you possibly can. And the earlier in the day you do it. If you're taking a nap later in the evening, it's just going to disrupt that sleep onset, which many of you felt like was a problem for you. And you really have to say, what are the benefits? If you're so tired that you're napping, to me, that's a sign that your sleep hygiene and your nighttime sleep habits are not probably what they should be. But you say this, I don't have time to sleep. I'm too busy to sleep. Isn't that what we're saying? Remember, your time and attention, your energy, what you spend your mind doing, it's your most important resource, and it deserves your most thoughtful management. And I'm guilty of this. I must say, sometimes the news will drive me crazy. And so then what am I doing? I'm spending more time reading the news, and it makes me crazy. So if I think of what am I spending my time and energy doing, manage that so that it's serving your function profitably. Do you take time for exercise? Do you take time for a good diet? Contemplation, mental well-being. These are important things of a good lifestyle. I bet many of you are spending time on those. Spend some of that time on sleep, because sleep is fundamental to a healthy body. And so when you're busy, ask yourself, which is more important, self-care activities or the thing you're doing? And of my self-care activities, I mean, I could spend my whole day exercising, eating a good diet. I got to get some work done. That's true. But I feel like sleep often falls to the bottom of the list, and I'm encouraging you to move it up just a little bit. Seek professional help if you have a serious health problem. But in general, I'm repeating myself, sleep is a basic biologic function. It's important to our health, well-being, and performance. Poor sleep has serious negative consequences, and establishing healthy sleep practices can prevent the sleep problem and promote a healthy life, I think. Signs and symptoms of sleep difficulties like sleep apnea or other things, medication issues, consult a doctor or a professional about those things. That's all I got. Sorry, I talked a lot there, didn't I? Are there folks that got some questions here? I can't see my chat window. So if somebody wants to, shall I stop sharing my screen? Is that what I should do? Do that. Noel, if you can share anything that gives me if anybody has, oh, there they are. Wait a minute, I see it. Cool. I'm sorry, I missed those things. I'm going to go fast here. Who determines how much sleep you are to get? How much Americans get? Yes, so there's some biologic variation, and there's some people who have this early chronotype, late chronotype, so there's some biology there. I think if you're not getting enough sleep, I think you know. The greater prevalence of parasomnias in women versus men related to misuse of sleep agents. That's a great question, and I don't know the answer to that. Somebody commented, read from a hardback book. I like that. It's old school. And maybe sit up and don't do it in bed. Let's see. Somebody had a question. I just see this. Snoring husband isn't an option. Sorry about that. How much time should be in REM sleep? And again, I think REM sleep gets a lot of press because it's kind of interesting. It's dreaming and stuff like that. But I think actually it's those stages, especially stage 3, that deep, slow wave sleep, that's the most restorative. I think for most people, it's about 15% is spent in REM sleep. Is it true the later you go to bed, the more sleep you require? No, the duration of sleep that you need is probably for you as an individual. There are these chronotype ideas that some people tend to go to bed late and get up late, or go to bed early and get up early. I must say the biology behind that and the science around that is not great. What about taking melatonin before bedtime? Will that help? Yeah, I think melatonin is a hormone. It's not a potent hormone, but definitely I think of it as a natural sleep medication. I think it's better than some of the other medicines that are more sedating. A person with obstructive sleep apnea who's overweight or obese loses weight can eliminate the need for CPAP. Yes, great point. Bariatric surgery is the most effective treatment we have, and the need for CPAP goes way down after that. Even weight loss through lifestyle or medications can reduce the need for CPAP. A number of good studies on that area. How much time in deep restorative sleep? Again, I don't have a great answer for that, other than I think if somebody has disrupted sleep, like sleep apnea or things like that, what happens is it takes you a while to get to that stage. So that's why you have to have enough time so that you're getting to that deep stage periodically. But I don't have a good answer for the exact duration of time. QA button on the bottoms. Oh, there's a lot of questions there, aren't there? Some say I only need 3 or 4 hours of sleep. How can one assess if you're getting your biologic sleep needs? I think it's those things. If you're tired during the daytime, if you're having trouble concentrating, these are symptoms of too little sleep. I don't know of scientific evidence that there are people that can go years and years with just 3-4 hours of sleep. CPAP is the gold standard for sleep apnea. If so, can wait. I think it helps, but it often doesn't cure sleep apnea. Does sleep help with rheumatic arthritis? Great question. I don't have a good answer for that one, other than it does affect immune functioning. That's sort of that bi-directional thing, that pain can make somebody not sleep well, but poor sleep can make somebody more sensitive to painful symptoms. If one's sleep time is later, but duration is enough, would this be okay? And again, I don't have a great answer for that. I do think, I keep in mind that biology, that when it gets dark, that's when our body usually sleeps. So how do you stay up past midnight? You turn the lights on. So I think what you're really doing is you're shifting the biology later. And you know what? I'm sorry, I don't want to keep people too long. There are some great questions here, but I feel like maybe I should stop so people can feel free to go. Should I do that? Oh, Taylor, yeah, because we have to do stuff, don't we?
No, that's okay. I just wanted to thank you. If there are more questions and you want to reach out to Dr. Bessesen offline, but I just wanted to thank you tonight for taking the time to share your expertise and tips with this group. It was a really awesome topic to check in on, and clearly has a lot of people have great questions about the topic, of course. So thanks everyone for coming. I hope you'll be able to join us for the next event in the series on August 12th, when the Director of Behavioral Health Education, Dr. Alex Reed, speaks on the managing your mood and enhancing wellness through COVID-19. So it'll be a good for these times, and I'm looking forward to that. So thanks so much for tuning in and for all you do as healthcare professionals for our campus and community, and we hope to see you again soon. Thanks so much.
Thanks, everybody.